We can start up with any of those rules. So basically, first vector, let's say, is this. So this is basically coming in here, right? And then that's the second vector. So based on parallelogram law of vector addition, I can place it here, right? And
Okay.
basically create a parallelogram somewhat like this. This is all rough work that's not to be done just to understand the, analogy. So this would then represent resultant, right?
Yes.
Because that's the direction of aircraft and that's the direction of it. So that's what, the resultant should be. So if I have to sketch it here, so what do I do? So I'll go about something like this, you know, something here like this that would represent the resultant velocity. Do you get this part?
Yes. Yes.
So basically, since it is a 1 mark question, so we are not required to, do any drawing, but we can do drawing if they want us to have, drawing question. Now they say determine the magnitude of the resultant velocity. So we very well have the direction of the resultant velocity. Now they want us to find out the value of it. So how do we go about it? So any suggestions?
Yes.
So let's say, for my understanding, what I can do, I can use my tip to tail rule. So that's one of the sides of maybe the rectangle or the triangle. And then the other vector was somewhat like this. And this was 95, and that's 28, right? Now,
Yes.
then I concluded my resultant to be somewhat like this.
Yes.
That's R. And I'm working for this. And the data, which I have here is the angle between, what do I have? So that's west, right? And this angle here is 65. Is that correct?
Yes.
That means I can find this angle out. So that should be 180 minus 65, right?
Yes.
So 180 minus 65 comes out to be 115.
Yeah.
So now I can use cosine rule because in this triangle here, I'm having two sides, right? And an unknown side and an angle opposite to it, right? So cosine rule analogy is basically r squared equals 95 squared plus 28 squared minus 2 into 95 times 28 times cos 115 degrees. Sadim, do you get this part, what I'm doing here?
Oh, yeah. Yes.
Okay, that's nice. So then I can find my r squared, and finally the r squared term comes out to be 12100, and then r comes out to be square root of the answer. So that's around 110 meters per second. Do you get this?
Yes. Sir.
That is nice. Let's try another question.
Sir, can you go up again to that question? Is it 95 squared plus 28 squared minus 2 in brackets 95 times 28 times cosine 115?
Yeah, this was the working.
Okay.
Done. Can I erase this?
Yes.
Yeah. Let's try this question.
Sir B.
Yeah.
Sir, which past paper question is this?
think that's the syllabus reference, 2017. Can you scroll down?
Oh, yes, sir.
So that's the question here. Would you be able to try this question yourself, or shall I help you?
I can try myself.
Okay.
Done, sir.
So yeah, your answer.
Yes, 65 by using the cosine rule.
Yeah, that's nice. That's good. So that was an exactly similar question, but with a different shape. Let's try this. So this is the syllabus reference here. That's 2016.
Okay, one second. Done, sir.
And then that's the question in part B. So let's see how do you sketch this up. So what you have to do is you have to draw it on a piece of paper, maybe on my screen. And if you're drawing on a piece of paper, then you have to send me a photo. Okay.
Okay. So does it have to be to scale?
It says a sketch. So
Oh,
you
so
don't have to draw it to scale.
okay. So how do I draw this?
So the question refers to there is a girl that runs 120 meters due north in 15 seconds, and then she runs 80 meters due east in 12 seconds. So first thing is sketch a vector diagram to show the path taken by the girl to enable her resultant displacement. So the only thing they want us here is the resultant displacement. So 120 meters north and 80 meters east. Well, that's the direction they want us to start. So there are two informations. First is 120 meters north. So if you start up with that, so it would be somewhat like this, right?
Yeah, okay.
And then 80 meters east, that's the second piece of information. So now she's here. So now she goes east, 80 meters. So, kind of a smaller length than what we did previously, because we have to have the difference in 120 meters and 80 meters, and then we can show the resultant. So that would be the resultant using tip to tail rule. Do you get this?
Yes.
Now, I want you to try also part two. Would you be able to do it?
Okay. So 7.4 meters per second.
Average speed. Please solve this.
So I can't hear you.
Yeah, that is correct. 7.4 meters per second is the average speed.
Okay.
Now let's try part two. So there are two things which they want us to do now. The magnitude of average velocity and its angle with respect to the direction of the initial.
So I don't get the question.
Okay, so they say you have to find out the magnitude of average velocity and its angle with respect to the direction of the initial point. So the question now turns to velocity, right? So velocity basically comes through displacement, right? And if you figure on the question, there were two informations, 120 meters north, right?
Yeah.
And 80 meters east, right? Is that correct?
Yes.
Now, the I have two displacements, right? Now I have to figure out how can I find out velocity. So first, to find out velocity, I would require my resultant displacement, because velocity is displacement per unit time, right? Is that understood?
So it would be 144 displacement.
And how is that so?
120 squared plus 80
Yeah, yeah,
squared
yeah,
whole
yeah,
square.
that's correct. Yeah. So displacement would be 144 meters, and total time that was around, I think, 27.
Uh, yes, 27.
So 144 divided by 27 is going to be 5.33 meters per second. You get this? That's the magnitude. Then they want us to find out an angle. So how do we figure that out? So basically, since velocity is a vector concept, so we know it has to have a value in numbers, that's magnitude, which we did calculate here. And then it also have a direction. Now the direction of the velocity is basically due to the direction of displacement, right?
Mm.
So if we just find this out, that's 120 meters north and that's 80 meters east. So this direction is what they're interested in.
And
Sorry?
so you use tan inverse
Yes,
80 over
exactly.
120.
Exactly.
So you get 33.7
Yeah,
degrees.
exactly. So do you understand this?
Yes, sir.
That's nice. And I think you have not done these questions before, right?
No.
Well, that's the same. So now you are understanding it, right? Because these are a must-do question in P2. They, they repeatedly come in exams.
Okay.
So let's try another question. Yeah, let's try this question. So the syllabus reference is October, November 2015. And we plan on to do question D, part D.
Mister, can you just scroll up to the code?
Yeah, that is October, November 2015.
And it's question 11.
Yeah, and we have to do part D.
Okay. So sir, it would be so the arrow would be drawn like this. Sir, is that correct?
Sorry, I can't hear you. You have drawn a
Yeah.
sketch?
Yeah, on the screen to show the direction of the resultant velocity.
Yeah, that is correct. Good, nice. So you have to do part 2 as well.
Okay. So is the answer 12.2 meters per second?
Yeah, that is correct. So this was your first correct question, right?
Yeah.
Let's do one more. Then we'll move towards P1 questions and then towards the next topic. Let's start.
So 1 second, can I get water?
Yeah, sure, you can.
So do I do question 16?
Yeah, this is just for your syllabus reference. The questions relevant part is, I have to scroll down for that. So that's for
Okay.
your reference. Well, that's the question. Party.
Yes, sir. We need to draw a scale diagram, yes?
You can, or just you can draw a vector triangle. That doesn't necessitate you to draw a scale diagram. The question basically gives you a choice.
Okay.
If you want to draw a scale diagram, they have provided us with this space. You can just draw a vector triangle. That would be okay.
So would I just draw this? Wait. So if I would draw a scale diagram, I have to draw it on the other side with the same angle.
I didn't get.
If I had to draw a scale diagram, I'd use the same angle and draw it on the left side of the both velocity.
Yeah,
So I need to find the resultant force first.
resultant velocity. Yes.
So how would I draw a vector triangle scale diagram?
Okay. So basically, the question states that you are having this, one of the analogies. So on figure 1.1, you can draw somewhat like this. So this goes here. That's water velocity 1.8 meters per second, right? And then do you get this part?
Yes.
And then the resultant would be somewhat like this. So this becomes a vector triangle. This is not a scale diagram. So remember one thing, resultant is obtained from connecting the start with the end, always, regardless of the direction it has.
Okay.
Now, how would you proceed with this?
So his answer 2.6.
The final answer for the resultant velocity is 2.6 meters.
Yeah.
So how do you find these questions? Easy, difficult?
Easy.
Easy.
Yes.
Let's do one more then. So question number 17. That's the syllabus reference. And we are doing part C.
Yes, sir, could you just scroll up to the code again? Okay.
And we are doing part C.
Okay. Sure, can I join on the question?
Sorry, come again. Yeah, you can draw it on the question. Don't worry.
Sir, is this correct? Yes, sir.
Resultant. This
Yes.
goes on like this. So the resultant is correct.
Yes, sir, should I do the R2?
So sorry. I never realized. That's not visible. Yeah, that's not too.
Okay. So it's answer 6.6 newtons.
Yeah, that's what they asked us to show. 6.16.
So you do it by finding the cosine rule.
Yes, yes, exactly. That's the answer. Okay, now I think you're good to go with this scalar and vector concept. Let's try some P1 questions and then we'll move to the other topic. Okay.
Okay.
P1 questions are more like, not drawing and it's just analyzing. So, on. Yeah, let's try this question 55. Can you see my screen?
Yes, sir. So it'd be
B is incorrect.
no, sir. I said it would be
So you have an answer? You're thinking?
yes. This one. It's A.
Yeah, that is correct. Let's try another question. Let's try part 57. This question.
This one would be
So what's your answer?
uh mm, wait. One sec. B.
B is correct. That's nice. B ball is correct. Good job. Nice. Let's try this. 58.
This one would be uh oh, this one would be C.
Incorrect.
No? Oh, would it be wait. Oh, sir, would it be A.
Yeah, A is correct. Good.
Okay.
Nice. That's well a very simple and yet confusing question. Let's try 59.
C.
59 is C. That is correct. Let's try 63.
C.
3 is C. Correct. Let's try 64.
So B.
B is incorrect. 64 B is incorrect.
So how would you do 64?
So in 64, what they stated here is that the wind goes from west at a speed of 85 kilometers per hour. So that's 85 towards west. And they basically want airplane to fly due north. That means this is what they, are looking for, somewhat like this. They want us to fly north, right?
Yes.
So basically, he has to fly, somewhat this way. That would be the resultant here. So just let's make this simpler. So that's the resultant. If that's the resultant, then we can just fly here somewhat like this. So this becomes the resultant north. I don't know why is this happening. Just give me a minute. Yeah, that's
Okay.
north. That's what the desired destination is. So he needs to go this way, right?
Yes.
And The speed here is 200 kilometers. So basically, you can now work this out, right? So using Pythagoras theorem, you'll get 25.2, and the direction is west of north. Do you get this?
So isn't it does says the speed of an airplane in still air is 200 kilometers an hour. So wouldn't that mean it's going north at 200 kilometers an hour?
Mm, no, that's what I drew for still air. But the question is, he wants to fly north. So that's where I figured this out. Because the
Okay.
problem is the question never, shown us the direction of the speed of still air. So we have to figure that out through this resulting technique. Do you get this?
Yes.
Are you sure?
Yes.
That's nice. Then
So the answer what would the answer be for that
D,
one?
D doctor, D doctor.
Okay.
Let's try question 70.
So would it be B?
No, B is not possible. See, line of action means somewhere, here.
Oh, okay. Okay.
So
So C?
yeah, it can be C and A basically because both of these are kind of in
Oh,
similar direction. But what we can think is, this is 3 Newton here and 4 Newton here. So it should be, more towards this. So if you
oh,
compare
okay.
C and A, you'll see that, A is more towards this 4 Newton. You get this part?
Yes, sir.
Okay, that's nice. See, these are simple questions, yet they can, disturb us, in calculation. Let's try question 74.
Hmm. There's the answer B.
74.
Yes.
Yeah, the answer is B. And what about 75?
A.
Yes, correct. So nice. Let's try 77.
So is it D?
Yeah, D is correct. That's nice. Good. So now, Salim, I would request that do you have any access to past papers other than
I
this?
have saved my exams.
Yeah, save my exams. So please try, some questions from save my exams based on physical quantities
Okay.
and this is scalars and vectors and both P1 and P2 questions. Okay.
Okay.
So by Wednesday, I would want you to tell me that how many questions you have done in P1 and P2 from your resources. Okay.
Okay, sir.
Okay. So see you on the Wednesday class. Okay. Take care of us.
Okay. Allah Hafiz.